Good afternoon. I am Alpana Burman, Assistant Professor of Electrical Engineering Department of Huldia Institute of Technology. Today, I am going to discuss Introduction to Measurement System. So, as we know, any unknown quantity, let anything, the length of door, the length of bar, or the weight of potato, whatever we want to measure, we first of all we have to know what is the measurement system. So here I have written over there, the measurement of a given quantity is an act or the result of comparison between the quantity of unknown quantity and a predefined standard. That means what? First of all, let us to know. So I want to measure the length of a bar. Let this one. I want to measure the length of bar. So what to do? We need something by which we can measure the length of this bar. So here, that something which we want to need to measure that is called measurement instrument, or here I have written predefined standard. So with the help of that scale or tape, which will be our measuring instrument, using that one I am going to measure the length of that. Let the length of the scale is 1 meter and the length of this bar is 50 meter. So what to do? We have to compare this length several times. So it will be 50 into 1 length of this scale. So here we are going to measure that length. Obviously that will be represented with some numeric value along with units. So here we can say the length of this bar is 50, that is our numerical value, with unit, that is meter. So this is our measurement system. Next, already I have told you, measuring instrument, that is what by which we are going to measure an unknown quantity, that will be measuring instrument. So here according to this example, our scale will be measuring instrument. Okay, similarly using tape also we can measure the length of the bar. Now what is the evolution of instruments? So here we have different types based on evolutionary of instrument. So first one is mechanical instrument, second one electrical instrument, and third one is electronics instrument. So mechanical instrument, that is very bulky, size is very large, and as it has some rotating parts, so it will take more time to give us some value of unknown quantity, but it is reliable. Next one is electrical instrument. So this one is faster than mechanical instrument, and the deflection of the unknown quantity or the device, that can be operated by some electrical instrument or electrical devices, which is faster compared to mechanical. Next one is which is more faster compared to electrical as well as mechanical instrument, that is electronic instrument. And here the unknown quantity we can measure with the help of some semiconductor devices, which is very fast. Next, the measurement system as well as the measuring instrument can be classified into two types. One is absolute instrument and another is secondary instrument. And that classification is dependent on the form of outcome of the instrument. Now, let us know what is the meaning of absolute instrument. So here, the unknown quantity. Let we want to measure the current which is flowing through this resistance. So how to measure that? So to measure that we need some measuring instrument, but that may be absolute type of or maybe secondary type of. Now absolute type of means that quantity, I mean current, that is fully dependent on the physical constants of measuring instrument. As an example, tangent galvanometer, which gives as the measured current in terms of tangent, deflected angle, the radius and the number of turns of the diameter itself. That means it doesn't depend on other some quantity. That means which may vary with temperature or other some physical constraints. Okay. So here the value of unknown quantity, current will be very accurate. Accuracy will be more if we apply some absolute instruments, and basically this type of instruments are very useful for our research laboratories. Next is secondary instruments. Secondary instruments are those which we can observe. The value of unknown quantity we can observe from some deflecting devices, and those devices are not that much of accurate compared to absolute instrument. Now go to what are the secondary instruments and how we can represent all the unknown quantity parameters or values. So based on that, we have three type of instruments. One is indicating type of, then recording type of, and integrating type of. And all are presentation of our output of our unknown quantity values. So first one is indicating. That means here we have some indicating device or instrument. Let we have this kind of calibrated scale. Let we have this kind of calibrated scale, and we have a pointer which can move towards this scale. So let this scale range is 0 ampere to 10 ampere. So here actually we are going to use an ammeter which will be indicating type of. That means when this meter is connected with some parameter like R1, and we want to measure the value of current which is flowing through that resistor. So what will happen here? Let the value of this current will be 5 ampere. So this pointer will deflect, will move from its 0.2 up to, let this one is 5 ampere. That means what? Here our pointer is indicating our output, and as this value of current through this resistor will be 5 ampere, so this pointer will be stopped, will be fixed at this 5 ampere point. So this type of instrument is called indicating type of instrument, and this type of instruments are very available in our lab, where we have ammeter, voltmeter, wattmeter, etc. Next is recording type of. So here what is going to do over here, instead of this pointer, instead of this calibrated scale, we'll have some value, we'll have some pen or some pencil which will record all the values which you are going to measure with the help of some measuring instrument. We want to measure the temperature of this room for 2 hours. So what to do? We have to note down, we have to monitor all the values of temperature with respect to time. After that, we want to plot a graph. Our temperature variation, that will be this kind of. It may be this kind of with respect to time. So that kind of recorded value we can do, and also that kind of graph also we can plot with the help of this recording type of instrument. Next we have integrating. Integrating, that name implies what? Integrating means summation of several values. Like we want to measure power of a device. How much power will be consumed by a device. So what to do? We have to measure that power with the help of some wattmeter, and with the help of same wattmeter we are going to measure the value of energy. So what to do? As we know, energy is the product of power and time. So what to do? We have to first of all monitor several values of power, like P1, P2, P3. Okay, and that values will be monitored over a period of time, and that time will be multiplied with these all values of power. So that will be the energy conservation of that defined device. Okay, so that function we can do with the help of integrating type of instrument. As an example, energy meter. With the help of energy meter, we can measure energy, which is the product of power and time. Over a certain period of time, we can measure. Next, we have to know what are the methods by which we can measure any unknown quantity. So far, we know what are the instruments. What are the instruments we can measure to monitor or to calculate any kind of unknown quantity. Next, we have to know what are the methods by which we can measure an unknown quantity. So, two types of methods are there. One is direct method, another is indirect method. Now, direct method is again classified into two. One is deflection, another is comparison method. And comparison method again classified into two. One is null method and another is differential method. So direct method means let we want to measure the value of current which is flowing through a resistor. So simply we can connect an ammeter and we can see the deflection of that pointer where we can measure that unknown quantity. So here direct method means the measuring instrument that will be directly connected with the unknown quantity. Next, deflection method means something of the instrument that is going to deflect. Just I have told you same example as previous one I have given here. We have this kind of calibrated scale. And range of this calibrated scale is like 0 volt to 5 volt. So this is a voltmeter, and with the help of this voltmeter we are going to measure the value of voltage. So here this voltmeter that will be directly connected with the circuit. Here we have circuit. Okay, and next we want to measure the value of resistance. We want to measure the voltage of this given resistance. So obviously the voltmeter that should be connected in parallel with this resistance here. So here when supply is given from the source, what will happen? This deflector, this pointer that will move towards this direction. And then the value of this voltage which is dropped across this resistance, that is like 2 volt. So what will happen? The pointer will move from 0 to towards 5 volt, and when it will receive 2 volt over here, it will be damped in this position. So in this way, by observing the deflection of this pointer, we can measure the value of unknown quantity. Whereas the unknown quantity was what will be the voltage drop of this R1 given resistor. So this is deflection method. Next one is comparison method. That means we are going to compare something that will be our standard value or predefined value with the unknown value. So this is the length of a bar. Already I have given this example, and that example is nothing but our comparison method. So what to do? Let the length of this bar is 20 feet. And we have a tape or scale, whereas the length of this tape is like 2 feet. So what to do? Several times we have to compare this length with respect to the length of this bar. So the length of this bar will be this much. Then again we have to measure this much using the same length. Again we have to measure this length, and in this way several times we are going to compare this length of scale with the length of this length of bar. So this method is called comparison method, and that value will be written in terms of some numeric value with the unit of that scale. Okay, next we have null method. Null method is what? Let we want to measure the value of resistance using Wheatstone bridge. So already we know what is Wheatstone bridge. So four resistances are there and they are connected in this way. They are connected in this way. This is led R1, R2, R3 and R4. Okay, and there is a supply. And in between this we have galvanometer. And we know that at balanced condition, when the potential value and value of this voltage is same as the value of voltage in this point, at that time the circuit will be balanced and no current will flow through this galvanometer. And at this condition, we have to measure the value of R1, R2, R3 and R4. So the formula will be R1, R4 that is equal to R2 into R3. And let any one of them is unknown value. So what I have told you? So at balanced condition, no current will flow through this galvanometer. That means the deflection of this galvanometer will be at 0 point. I mean it will be fixed at its null position. So in this way, we can measure the unknown value of resistance using Wheatstone bridge. So that type of measurement is called null method because the pointer will be fixed at its null point. So first of all, you have to consider the null value. Then we have to balance this circuit, and at that time we have to measure all other three parameters to measure the unknown value of resistance. Similarly, we can take another example. Let we have to purchase some amount of potato. So what to do? So we have that balance weight. So there is some unknown value and that will be measured with some balance weight. This one. So what to do? There is a pointer and there are some potatoes and there is some balance weight. This one. So what to do? We have to compare these two parameters with respect to this null pointer. So when this null pointer is at 0, at that time we can say the weight of this potato will be this much. So that type of method is also called null method. Using this balance weight, we can measure that value. So let the sum of potato, that measurement is now 1 kg. So 1 is the numerical value and kg is the unit of this unknown quantity. And last one, that is differential method. So differential method means we are going to differentiate something. As an example, pressure measurement manometer. So what we know, we have two vessels. This is vessel number 1. Like here the pressure is PA and there is a U tube, this type of, and there is another vessel. This is like PB. So in this case, here we have to measure the pressure, which is the difference of these two pressure, that is PA minus PB. That will be PA minus PB. So we are very much interested to find out what is the pressure difference between two vessels. That is example of differential method, which is pressure measurement of manometer. Next one is indirect method. So what is indirect method? What is indirect method? Indirect method is directly we are not going to measure the unknown quantity. Indirectly we are going to measure the value of unknown quantity. As an example, we want to measure the value of voltage. We want to measure, or we want to measure the value of resistance, okay, which is connected in a circuit. We have this kind of circuit. We have this resistance, and we are interested to find out what is the value of this R2 resistance. So directly we are not going to use some measuring instrument by which we can measure the value of this resistance, which will be in ohm. But what we have another option, we can use Ohm's law. What is Ohm's law and what is the formula? So to measure that unknown value of resistance, we know we have to find out what is the voltage of this resistance, which is let V2, and we have to know how much current is flowing through that resistance R2. So if we know these two values, then using Ohm's law, we can easily find out what is the value of resistance. So what to do? To measure this current, we have connected one ammeter over here, which is in series with this resistance, and we have to connect one voltmeter that will be in parallel with this resistance. This type of. Now let's supply is connected like this. So what we are going to do here? Our task is we have to measure the value of resistance, but indirectly we are going to measure with the help of Ohm's law. So directly we have connected voltage, a voltmeter to measure voltage, and we have connected ammeter to measure current which is flowing through the resistance. Then V2 by I2, that will give us the value of resistance. So this kind of method is called indirect method. So today so far we have learned what are different type of measuring instruments and what are the methods by which any unknown quantity. And next lesson we learn what are the different characteristics of some measuring devices. So far, have a nice day and see you in next class. Thank you.